This is Chapter 5, Lesson 2, Sequences. So, a blank is an ordered list of numbers. So a sequence is an ordered list of numbers. Each number in a sequence is called a term. In an arithmetic sequence, each term is found by adding the same number to the previous term. Okay? So, if I'm looking at an arithmetic sequence, arithmetic just is arithmetic, so you're just adding things, okay? So numbers, continue each sequence. 1, 3, 5, 7. What are you going up by every time? That's right, 2. You go up by 2 every time. So 7 plus 2 is 9. So the next term in the sequence would be 9. Okay. The next one I have 1, 1.5, 2. What are you going up by each time? 0.5. So 2 plus 0.5 is 2.5. 2.5 plus 0.5 is 3. 3 plus 0.5 is 3.5. Okay. So in words, so the first sequence I added 2 to the previous term, and in the second sequence I add 0.5 to each term. Okay. So I'm describing and extending sequences. In an arithmetic sequence, the terms can be whole numbers, fractions, or decimals. So I can describe the relationship between the terms in an arithmetic sequence 8, 13, 18, 23, and so on. Then write the next 3 terms in the sequence. So each term is found by adding what to the previous term? I'm adding 5 each time. Okay, so 23 plus 5 gives me 28. 28 plus 5 gives me 33. 33 plus 5 gives me 38. So my next 3 terms are 18, 33, and 35. Okay. So when I write an algebraic expression, in a sequence, each term has a specific position within the sequence. Consider the sequence 2, 4, 6, 8. So 2 is my first position, 4 is my second, 6 is my third, and 8 is my fourth. Notice that as the position number increases by 1, the value of the term increases by 2. So 2 plus 2 gives me 4, 4 plus 2 gives me 6, 6 plus 2 gives me 8. Okay? So the position, first position is 1 times 2, which gives me 2. So a value of term is 2. 2 times 2 is 4. So I get a value of 4. My third position, 3 times 2 equals 6. So I get a value of 6. And 4 times 2 equals 8. So I get a value term of 8. Okay? You can also write an algebraic expression to represent the relationship between any term in a sequence and its position in the sequence. In this case, if n represents the position in the sequence, the value of the term is 2n. Okay? Part of the reason that we can do this is addition is, or multiplication is repeated addition. Okay? So I'm adding the same thing every time, but you can shorten that with multiplication, okay? So that's where the 2n comes in. All right, so let's try it out. There are 2 try it problems. Go ahead, pause the video, try them out. When you're done, we will go over the answers together. All right, now that you've had a chance to try them out, let's go over the answers together. Okay. So describe the relationship between the terms in each arithmetic sequence. Then write the next 3 terms in the sequence. So the sequence is 2.5, 3.0, 3.5, 4.0, and so on. So I have to describe the next 3 terms. So if my sequence is 2.5, 3.0, 3.5, 4.0, okay? What am I doing each time? I add by 0.5. So I'm going to take 4. 4 plus 0.5 equals 4.5. I'm going to take 4.5 plus 0.5 equals 5. Okay. And then 5 plus 0.5 equals 5.5. Okay. So my next 3 terms are 4.5, 5, and 5.5. Okay. And I add by 0.5 each time. Okay. The second one I have is the pattern shows 3 circles, 6 circles, 9 circles. What algebraic expression can be used to find the number of circles used in any figure? How many circles will be in the 50th figure? So, first thing I want to do is I want to go ahead and draw myself a picture. All right, so the first figure has 3 circles. Okay. My second figure has 6 circles. My third figure has 9 circles. What are you doing each time? From 3 to 6, I added 3, and from 6 to 9, I added 3. So I go up by 3 each time. So 3 times my term, n, is my expression. So if I wanted to figure out how many circles were in the third term, I would take 3 times 3, which would give me 9. Okay. It asks me for the 50th term. So I'm going to take 3 times 50. When I multiply that out, I get 150. So the expression I use is 3n, and there will be 150 circles in the 50th figure. Okay, and that is the end of lesson 2.